Morning, everyone. Welcome back. Thank you for joining us. We are glad that you're here. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings, Science and Technology channel.
Yep. And I am in the secret bunker in Utah, and Steve is in Apple Valley.
Yes, sir.
And we're talking about something that everybody uses, I'll bet, almost every day. And a little bit of a change here. So here we go.
Yeah, this is a great breakthrough. A new solvent-based technique could change how lithium is extracted from brines. Now, Scott, the Salton Sea has got lithium at the bottom of it. So this is
big deposit.
Yeah, this is groundbreaking.
Big deposit.
Salton Sea is like south of us towards San Diego, but on the east side of the mountains. Potentially making the process faster, cheaper, and viable in places where conventional methods fail. Few elements are as key to the clean energy transition as lithium, and global demand for it is soaring. The metal powers the rechargeable batteries inside electric vehicles and the massive storage systems that allow solar and wind energy to supply electricity long after the sun sets and the wind calms, in addition to the many power tools that we use on the job site.
Right.
Unfortunately, current methods for producing lithium are slow and require high-quality feedstocks found in relatively few locations on Earth. So, would you like to know more?
Yeah, and along with phones too, right? Phones have lithium batteries.
Yeah, phones, computers, laptops.
Ironically, the environmental costs are also significant. Refining the mineral behind clean energy requires large amounts of land and can pollute water supplies that local communities depend on. In a new paper, researchers from Columbia Engineering describe a method for extracting lithium that could dramatically shorten processing times, unlock reserves that existing methods cannot access, and reduce environmental impact. Their technique uses a temperature-sensitive solvent to extract lithium directly from brines found in deposits around the world.
Well, I'm all ears on this one.
Yeah.
Unlike current technologies, this approach can efficiently extract lithium even when it is present in very low concentrations or mixed with chemically similar materials. The results, detailed in a paper published in Joule, Joule, that's a method of measuring energy, on January 21st, 2026, show that the innovation called switchable solvent selective extraction, S3E, switchable solvent selective extraction, can extract lithium with strong selectivity. Suffrage. Up to 10 times higher than for sodium and 12 times higher than for potassium. The process also excludes magnesium, a common contaminant in lithium brines, by triggering a chemical precipitation step that separates it out.
Roughly 40% of global lithium production begins with salty brines stored in large underground reservoirs beneath deserts. Nearly all of that lithium is extracted using a technique called solar evaporation, in which brine is pumped into sprawling ponds that bake under the desert sun, sometimes up to 2 to 3 years, or up to 2 years, until enough water evaporates. Interesting.
This approach is only feasible in dry, flat regions with vast areas of land such as Chile's Atacama Desert or parts of Nevada. It also consumes large volumes of water in places that can scarcely afford it. Quote, "There's no way solar evaporation alone can match future demand," said Nwai Yin Yip, Levon Duddleson Crum Associate Professor of Earth and Environmental Engineering at Columbia University. Continuing his quote, he says, "And there are promising lithium-rich brines like those in California's Salton Sea, where this method simply can't be used at all."
And there is no way that Steve made that name up. There's no way. Okay. Unlike conventional lithium recovery methods, S3E does not rely on binding chemicals or extensive post-processing. Instead, the process exploits how lithium ions interact with water molecules in a solvent system that changes its behavior with temperature.
At room temperature, the solvent pulls lithium and water from the brine. When heated, it releases the lithium along with water into a purified stream and regenerates itself for reuse.
In laboratory tests using synthetic brines modeled on the Salton Sea, a geothermal region in Southern California estimated to contain enough lithium to supply more than 375 million EV batteries. That's a few. The system, that's a big deposit, like we said earlier. The system recovered nearly 40% of the lithium after just 4 cycles using the same solvent batch. That performance suggests a potential path towards continuous operation.
I tell you, Scott, we need to get to these lithium deposits in the Salton Sea. The climate huggers here in California need to give it up. This is clean energy, the batteries.
Yeah, this is another oil thing. You know, our state is rich in oil, and the tree huggers won't let them do that. It's crazy. But anyway, yeah, you're right. Absolutely.
Quote, this is a new way to do direct lithium extraction, said Yip. It's fast, selective, and easy to scale, and it can be powered by low-grade heat from waste sources or solar collectors.
The team emphasized that this is a proof of concept study. The system hasn't yet been optimized for yield or efficiency. But even in this early form, S3E appears promising enough to offer an alternative to evaporation ponds and hard rock mining, the 2 approaches that dominate the lithium supply chain today and come with steep trade-offs.
As the global clean energy transition picks up speed, technologies like S3E could play a crucial role in keeping it on track by making it possible to extract lithium faster, more cleanly, and from more places than ever before. Like the $6 million man, right?
Yeah. Quote, we talk about green energy all the time, said Yip, but we rarely talk about how dirty some of the supply chains are. If we want a truly sustainable transition, we need cleaner ways to get the material it depends on. This is one step in that direction. I agree. Sounds good.
Sounds
faster,
real good.
cleaner.
Let's get it into operation and get some testing and get it going.
Yeah. Turn it over to the private sector and let them run with it. Get government out of the way. Let the private sector run with it, and they'll figure it out.
Find a way. California find a way to regulate it, get some tax out of it.
Yeah. But, you know, there's lots of places that are like the Salton Sea, with the exception of live water on it. There's lots of dry lake beds in Nevada, in parts of Arizona, which I don't know. Maybe they've studied those and they haven't found any of them. But the Salton Sea is not.
Utah too.
What's that?
Utah also.
Yeah, Utah as well. Absolutely. Like Great Salt Lake. Why are they looking up here? I mean, it's just crazy. So, but we'll see.
All right, folks. Thanks for joining us. We'll catch you in the afternoon.
Take care, everyone. Thanks.